Today we're going to be discussing box and whisker plots. And so you're going to be given a set of data, and we're going to look and see how spread out that data is by using a box and whisker plot. All box and whisker plots are split into 4 equal parts. So from the end point up to the box, that's worth 25% of the data we're given. From the box to the middle of the box, that's another 25%. From the middle to the end of the box represents another 25% of the data. And then from the end of the box to the end of the whisker there is the last 25% of the data. So we're splitting it up into 4 equal parts. Now, each one of there's several points on a box and whisker plot that has special vocabulary names that we're going to discuss, all right? So the first one is going to be called this endpoint right here, which you can see is located on the number line at 16. All box and whisker plots are on a number line. That 16 is what would be called the lower extreme. Just another way to say the smallest number that we were given. Then at the start of the box, which is on 18, that right there is called the lower quartile, and we'll discuss how to get that in a little bit. The next part is the line going down the middle, which is at 22 on the number line. That line represents the median, and you might remember from previous years, the median is the middle number in a set of data. The next part is what's called the upper quartile, and you can see your upper quartile is located at 26. And then the final number that you're given is going to be called the upper extreme. And that number today is at 28 on the number line. So that's the largest number in my data set. So by using a box and whisker plot, you can tell what the smallest number is, what the largest number is, and what the median number is. And then you can also tell the lower quartile and the upper quartile. So now we're going to discuss what these mean. So the lower extreme, you've already seen, is the smallest number in the data set. Sometimes they call this the minimum. And then at the other end, you saw we are given the upper extreme. Which is the largest number in the data set. A lot of times you'll hear us call this the maximum. Then you're given in the very middle of the box a line cutting through. That's called the median. And if you remember, the median is the middle number. But because we put these on a number line, we have to order them from least to greatest. And the median, remember, goes inside the box. So we always have to order from least to greatest our data and then find the middle number, the median. Then the other 2 words, which one of them is lower quartile, and what that is, that's another median of the lower half or the bottom half of the data set. So if you notice, our median splits our data down the middle. So the lower quartile would be if you just went from the lower extreme to the median and counted into the middle, and that would be the lower quartile median. And then you would do the same thing for the upper quartile, because the upper quartile is the median of the upper half of the data. So from everything from the median all the way to the end or the upper extreme, the highest number. So basically, when we're doing box and whisker plots, we're finding the median 3 times, the smallest number and the largest number. So let's go and answer some questions down at the bottom. Which score represents, and by the way, this is using the box and whisker plot below. We're summarizing bowling scores for 19 students. So which score represents the median? Well, the median is always going to be the middle number. It's inside the box, and it's the middle number in the box. So that's going to be C, which is 143. So 143 is the middle or median score. Then it says, what percent of students bowled between 81 and 162? Well, if I know, I'm looking at my box and whisker up there, and I'm seeing that 81 is the smallest number, and that's my whisker, and then I have the box, and then at the other end I've got 219, which is my largest. It looks like my lower quartile is at 105. The median of the entire thing is 143. And then the upper quartile median is at 162. So if I want to go from 81, that's 25%, up to 105, and then from 105 up to 143, that's another 25%. And then once again, from 143 up to 162, that's another 25%. So 25% plus 25% plus 25% means that if you go from 81 to 162, 75% of the kids, of the 19 kids, would have bowled between a score of 81 and 162. So let's take a look at another question. So use parallel box and whisker plots at the right. In other words, you've just got 2 box and whisker plots on one number line, and you're comparing what they give you. So it says, which set of data contains the least value? So remember, the least value is the number at the end. So A is right here, which looks like it's probably at about 25, and B is at 20. So set B would have the smallest value. Now we're going to look see who's got the greatest. So A looks once again like it's about at 65, and B looks like it's at 70. So B would also contain the greatest value. The other 2 questions we're going to come back to later, because we want to focus on now how to draw a box and whisker plot. So you're given a table, and it says calories in 1 cup serving of fruit, and they list fruits and then each of their calories per 1 cup serving. So we're just going to literally follow the steps. And you see there's a lot of steps, but I broke them down so that you could figure out how to do these fairly quickly. So the first one says, plot the smallest value in the data set. In other words, we got to plot the lower extreme. So I'm going to go up to my table there, and I'm going to find the smallest number. And it looks like the smallest number is strawberries, 45. So I'm going to go to my number line, and I'm going to put a point at about 45. Step 2, plot the largest value. Okay, so we're going to plot the upper extreme. So looking at my graph there, or my table, I can see that 113, the grapes, has the most calories. So I'm going to come up here and put a point at about 113. Okay. Step 3 says, order the numbers from least to greatest, because we need to find the median. So what you're going to do is you're going to take all the numbers from the table and order them from least to greatest. So 45 is smallest. I'll mark that one out. The next one would be 69, and I'll mark that. Next one is 73, 81, 84, another 84, 90, and then last 113. Okay, then it says find the median of the data set and plot it on the number line. Okay, so what you can do is put your fingers at each end of the data set on 45 and 113. And what you do is literally just count till you get to the middle. And hopefully you get to one number in the data set. But if you don't, like I did, I landed on 81 and 84, which tells me both of those numbers are in the middle. And so when that happens, what I'm going to have to do is find the average. In other words, you've done this before, 81 plus 84, and then split it or divide it by 2, which gives me 82.5. So 82.5 is going to be my median. So I'm going to come up here to the number line and plot my median. Now the next thing says, split the data in half. So when I do that, I have two sets, a lower half and an upper half. And so I'm going to find the median of the lower half, and this will be my lower quartile. In other words, where my box is going to end. Or I guess I should say my box starts and my whisker at the other ends. Okay, so what I'm going to do is once again, I'm going to count in, and I'm going to see that I've got two numbers in the middle again. So I'm going to have to do 69 plus 73 divided by 2. And when I do that, my lower quartile median is 71. So I'm going to plot my point right there at 71. Then I'll do the same thing for the upper half. And when I count in, I get two numbers. So I've got to do 84 plus 90 all over 2. And when I do that, I get 87. So my upper quartile median is 87. So I'm going to plot that right there. And now it says box up the lower quartile median, upper quartile median, and median. So every median that I found becomes a box. And then my whiskers are to my extremes. And that's how you draw a box and whisker plot. Now, sometimes they're going to ask you questions like, what's the range of the set of data and what's the interquartile range? All that means to you is for the range, that's the largest number minus the smallest number in the data set. And you all already found that. The largest was 113, the smallest was 45, so the range is 68. Now, when you want to find the interquartile range of the data set, all that means is the range of your box. So you're going to take the upper quartile, which we found to be 87, and you're going to subtract off your lower quartile, which we found to be 71. So the interquartile range is 16. So now let's go back up to the top of your paper here, and we're going to answer a couple of these questions. So 22 says, which set of data has the greatest interquartile range? So now that we know what that means, I can see that the upper quartile for A is at 60, and the lower quartile for A is at 30. So 60 minus 30 gives me an interquartile range of 30. That's A. For B, I see that my upper quartile is at 60 and my lower quartile is at 40. So that range is 20. So A has the greatest interquartile range. Now for the which set of data has the greatest range, I already know that B has the largest value and the smallest value, which tells me that the range 70 minus 20 or 50 will have the greatest. If you did A looks like it's at about 65 and it looks like it's about at 25. 65 minus 25 would only be 40.